Hello everyone, welcome to Practical GCP. Today, I would like to share a design and also a end-to-end working solution on how to decrypt files landed on the GCS bucket, but is GPG encrypted using a Cloud Run service. So first of all, I'll be covering what is GPG or what is GnuPG. Then to talk about why this is a common problem that we very often facing and need to solve. Then we'll look into the actual GPG Decryptor service, the architecture diagram of it, and how does it work. I'll then show a few more details on how to use GPG, which I think is important because it's important to understand the fundamentals of how GPG works, how to install it, how to generate and import or export the keys, to use it with Secret Manager in this particular case, and then we'll get into the code. So finally, we'll see it in action. So I've got a live demo to show it to you exactly how this works with to have an encrypted file, have it decrypted via the service. So what is GPG? So I've got a rather neat explanation from ChatGPT. It's a GNU privacy guard, and it's an open source implementation of the OpenPGP standard for encrypting and signing data and communications. So it's very good for encrypting files for all use case. And if you look at this, right, so the GPG encryption is also a form of asymmetric encryption. That differs to the ones that crossed out, which is symmetric encryption, in the sense that if you are the data receiver, you want someone to send you data, especially if the data is sensitive, which you might want to encrypt it, right? You want to encrypt it first. So with asymmetric encryption, or in this case with GPG, you generate a private and a public key pair, two keys, kind of attached, linked to each other. The private one is the one you keep it to yourself. You don't give it to anyone, right? And then the public one, you export and send it to the third party or the data owner who wants to encrypt the file. They can use the public key to encrypt and only to encrypt, right? So the reason it's called a public key is because you can share it with anyone you like. The only thing they can do is to encrypt the file. So in this case, you have some clear text file, you encrypt the file, that becomes the encrypted file. So now it's safe to transfer those files via things like FTP servers, which are not typically has encryption at rest, right? So then go through the internet and it reaches to the data receiver here. The data is now encrypted. You have the private key. You decrypt the data. You see it in clear text. So however, in symmetric encryption, you do not have a key pair. You have one key. Typically, you use that to encrypt your data and decrypt your data in the same location, the same place. You just you don't want to store it clear text at all, but you're not actually using it to send, it's not used to send data, encrypted data, to a third party because you do not want to send around your private keys, right? So this is why asymmetric encryption is very, very common in this use case for transferring encrypted data or files between parties. So what is the problem we're trying to solve? So think of the two following cases, right? So in the first scenario, you may be dealing with very hypersensitive data, such as the data in HR systems as employee data, the data in the banks or healthcare have hypersensitive patient data. If you transfer the data from these systems into a cloud storage bucket, although everything in transit and at rest for cloud storage is always encrypted, you still do not want the data to be sitting clear text if you have the permissions. So in a large organization, it's very easy to accidentally give someone a role to see the storage bucket. What you want to do is there are two layers. One is you give someone a role, they can only see the encrypted files. Then you have the decryption, you have to decrypt the files, and then you can actually see the content. So it's not like you make one mistake, then is a big mistake, right? So there's two layers. The second use case is it's 2023, but you still get these use cases that coming from older systems or third parties that cannot transfer data directly into the cloud storage bucket. I'm not entirely sure why, but it does happen, right? So they have some sensitive data they need to send it to you, but they cannot send it to the cloud storage bucket directly. So what typically happens is they need to do some form of encryption, right, of the files, typically in the files, and then put them into FTP servers then for you to get them, right, and then put it to your own cloud storage bucket. So this is a problem because the FTP servers are typically not encrypted at rest. So if your file gets put in there and then they are sensitive data, they're not encrypted, if you have a breach, it's a huge problem. But if you encrypt them, then it's safe. So in both use cases, this is where GPG comes in. So now let's look into the design. So what is the GPG decryptor and how does it work? So let's look at the diagram from the left to the right. To start with, you have a bucket which has the encrypted files. So these are ending with the .gpg extensions. What you may not know is when the file lands, you can optionally, right, this is something you need to run a gcloud command to set up, to make it fire the file drop event into a pub/sub topic. So that event contains very rich metadata, including the type of the event got fired, the name of the bucket, the name of the object, which you can subsequently do something about it, right? So this is event trigger. Then we set up a pub/sub push subscription into our Cloud Run service. So what this does is the event will come into our Cloud Run service, then we can actually do this is the GPG decryptor in the Cloud Run itself. So we can use this to decrypt all files. In this process, we need to dynamically pull a private key which we generated and exported and stored in the secret manager. So keep in mind, you never share the public key, you never share the private key with anyone. You put it into a secret manager and you pull it dynamically. You import it into the GPG, the Cloud Run instance, right? Dynamically decrypt the file and then store it in the cloud storage bucket. And then this Cloud Run service then gets scaled down itself. So everything is kind of a clean state. So in the last storage bucket, that's where you see your decrypted files. So the whole thing in the Cloud Run service happens in memory, including the decryption process. So there's a few more details I would like to go through about GPG. So there's 3 points in here. So one is how to generate and export keys. So earlier I talked about secret manager, right? So we need to generate keys and then we need to store them in secret manager. But how do we do that, right? And then the recipient. Then finally we talk about trusting the imported keys. So this article, this blog post from John on GIST is very powerful and lots of content covering exactly what you need to know on using the GPG service, from installing it, right, and then the generating and exporting the keys into trusting the keys. So it's all here. So one of the key things in here is, as you can see, once a key is generated, you have a recipient, right? This email address is the recipient. So what this does is you need to be able to associate the key with the recipient. So this is used for encryption and decryption. So the recipient is important because that's how you identify, for example, especially when you decrypt the content, this is how you associate with your private key when you're doing the decryption. And in addition, it's also important that you need to trust the key in order to use it. So when I initially tried it on my laptop, right? So I didn't have to do this trusting part. And I think the reason might be because I generated the key from my laptop itself, but I wasn't actually importing it dynamically. So keep in mind what we're doing here is we're using Secret Manager. We store the key in Secret Manager, but when a Cloud Run service runs, it pulls the key and then importing it into the local GPG service directly, right? And then decrypt your content. So this is when I found out you must trust the key, right? You must trust the key before you can use it. Otherwise, all you're going to get is a empty string because you can't actually decrypt the content. So it's not very obvious. That's why I'm kind of mentioning this. So you understand if it doesn't work, if you're doing the dynamic key import, is mostly caused by this. Okay, now let's look through the code. So I have a rather simple README, but it should have everything you need to know covered in here. The first section of the README reiterate the point I made earlier about how to generate and export keys. I've linked the article from John. This also includes how to export a private key, which isn't included in that article, but it's basically just using the export secret key flag. Then you can put it into Secret Manager after you've done that, right? So, and then also the public key, you can export it in this way. Recipient already explained, which is something you always have to specify when encrypting and decrypting the data. And then finally, you need to make sure you trust the imported key if you do it dynamically, otherwise it won't work. So the repo is structured in a way that you have the encryptor example. This is if you look at this again, right? So we have the encrypted files. In order to test this solution works, I need to have something that as a code snippet to generate a encrypted file. So this is what this file does. So let's look at this one first, and then we'll come back. Next one we'll look at the event message format and the content. So this one, very simple module. The easiest way to look at this is from here, right? This is the main bits. I've got a public key, which I retrieved from the Secret Manager. And then this bit is the GPG initialization process. So as you can see, I'm importing the key dynamically from Secret Manager, right? This is what that import keys does. Then I'm trusting the key using a fingerprint. This is what you can get when you list the key using the GPG command line tool. Then it will give you a fingerprint in the key. Finally, recipient, which we will need in order to encrypt the data. I've generated a in-memory CSV, which gives me a file stream, which I then use get value to get the content of the file, specify the recipient, encrypt, then I get the encrypted data. If this didn't fail, then this object would not be none. Otherwise, I'm raising an error because it didn't work, right? So finally, to make this look clean, I've generated some date parts that would give me a nice formatted year, month, day as like a folder-ish thing in the GCS bucket. Then I have the file prefix, the timestamp suffix, .csv, .gpg. Finally, I upload it to the GCS bucket. So this is the encrypted part. So now let's look at the event that contains the metadata that this file, when the file is generated and uploaded, it will trigger. So under the example folder, we've got the test message and the unpacked message. So this one, the difference is the test message has everything, but the data is base64 encoded. This is something you can use for integration tests because this gives you exactly what you get through the pub/sub push notification, right? So to your Cloud Run service. But there's a few things that are very important I want to go through. Under message attributes, you've got the event type. This is the thing is very important when you write code. You want to make sure you check this because there's many form of events can be generated when a file lands. It could be file being removed. It could be permission changes. But we only care about the finalized part because this is when the file has been successfully uploaded and we can do things with it. The data component is the actual payload with the information of your file object itself, which is it has a lot more details than the attribute itself. Message ID, which is the message ID in PubSub, then you have the subscription name. If you look at the fully unpacked version, under data, you've got a few things that are very important. Name, this is the name of the GCS object, and this is the name of the bucket, and then you also have the size of the file. So these are all very important information. When you process the decryption in the Cloud Run service, they would become handy. Next, we look at the Cloud Run service itself, which is basically we wrap the Cloud Run service, and then the actual service itself is in the decryptor.py module. So again, few environment variables, but at the bottom, you can see this is the bits that we do the initialization. Because this is a push subscriber, right? So it will make a HTTPS call to our app root endpoint to give us that message payload we just talked about. It's very important. You want to make sure you initialize this whole thing, so right, from the Flask side, the key retrieval, the GPG initialization outside of the app root, right? Because if you do it inside, that's going to be per request. If you have multiple files, quite a lot of files in a short period of time, this can reach the quota, especially on the secret manager service, which is not great. So you must put this outside of the roots. So it only does it once per Cloud Run instance, right? It doesn't do it multiple times. So then you can reuse it. So this is the same, very similar to the encryption. You've got the initialization, retrieving, however, this time is the private key, right? Not the public key. You've got importing the private key, then you trust the key, you add the recipient. So this code block is now the decryption code block. Envelope is what we talked about earlier, is that message payload. And then, as you can see, you've got the event type in there, which is the one that we are interested in only if it's finalized. If the project isn't finalized, for any other events, we basically ignore it. This is important because otherwise your message is going to fail because you won't have the things you need. The payload, as you can see, the base64 encoded, we have to decode it first, and then you have the bucket and the name of the object. Now we run decryption. Decryption is very similar to encryption, other than you just call the decryption method, you still need file in from the GCS bucket. So all of our processing is done in memory. This is deliberate. I'm not sure if you can actually do this using just a file stream or whether that's more efficient or not. But I don't really want to have the hassle of having to deal with files. So in this case, I've just done it completely in memory with the whole content. So Cloud Run does have pretty meaty machines, and from what I've seen, most files are not in the size of something like a Cloud Run worker cannot handle. So if you run into problems, you can modify the code to change it to files, but have not tried that myself. So yeah, but if you want to do that, you can have a look, give a go yourself. And then the next thing is, after we decrypted the file, we check if it's done correctly. Same as the other one. If this is none, that means it hasn't done it correctly. You probably do want to consider either logging this and return a success, or putting this in a dead letter queue, because if you cannot decrypt this, it could probably mean most likely your upstream sending the file has not done the encryption correctly, right? So then your key wouldn't have worked if this is the case. If that's the case, there's nothing you can do about this. So you better log it and then knowing what happened, because we already have all of these the events, which I'll show you later on. It's a quite handy way to store them. So you may not need that like a queue, but simply just safely ignore it, right? Finally, just a few manipulation with the dates and the destination bucket name, upload to GCS again, and then return code 200. right? So that's pretty much the whole thing. A few things around it. The Docker file itself, you need to install GPG. You need to create a virtual environment and install all of the Python dependencies, including GnuPG, right? Don't use the default Flask server. That's not for production. So put a GnuPG work in there, configure it to listen to a port, and then that maps to your decryptor app. And this also creates a app user, so it doesn't run this under root. The GnuPG config, basically you bind a port. So 8080 is the default on Cloud Run, so you can just use this. It's easier. You don't have to change it or anything. Workers 3, maybe 1 is better because it depends on your use case, right? If you have rather larger files, then you want to have better control of memory, because this is all processed in memory, then probably better to set it to 1, so you know you don't have workers splitting your memory usage. Docker Compose, this is quite handy. So you can see I've mounted the Google default credentials into the container, and then I also did some DNS hacks so you can actually access the internet. I mapped the port. This will allow you to use Postman on your local machine to do debugging, and also a bunch of environment variables. This is something I've kind of created for a last check before I deploy it. So, but you can also, if you want to do interactive testing, you can also change this to have another volume to mount the actual decryptor itself, the Python module. So then you can, whenever you make a change, you're going to see it reflecting in the container without rerunning it, right? So, and finally, the cloud build. So this is basically just a simple version of building an image, pushing the image, and then deploying the Cloud Run service. So it's quite straightforward. So these are environment variables you can set in this particular way. The things, however, I have not included in the source version control is many things kind of around it, like such as service control creation, the roles that we need to be granted. So I did not include that here because otherwise it would be too much content in one video. Right, demo time. Let's have a look at this in action. Remember this diagram. So we have to first generate a encrypted file. That should trigger a event that goes into the PubSub topic, which therefore subsequently trigger the push subscription to Cloud Run, pull the secret manager's secret key, the private key, dynamically import the key, then trust the key, does the decryption, put it into a target bucket, right? So let's have a look at the secret manager first. So I just want to show you that we've got a private key and a public key. So this is where they're coming from. I've already stored them. In order to make this work, so first of all, I will need to run the decryptor, the encryptor example, right? So this one, if I run it, right now, it should have just dropped a file into the GCS bucket for the encryption. So this is the encrypted bucket. If I refresh this, you can see that under the very nice date folder, I've got a file that is in GPG extension. If I download it, I want to show you the downloaded version and what it looks like. So if you look at the content here, right, you can see this is the encrypted message, the content, right? So what happens next is if I go to the actual subscription, go to edit, I've set this up as a push subscription. As you can see, it goes to the endpoint URL of the Cloud Run service I've deployed, and the push handlers receive message. So this is the one I've shown you in the source code, and that receives the message. I also have a service account set up in here specifically for this push subscription. And then keep in mind, in order to access this endpoint on the Cloud Run service, you must grant a role to this Cloud Run service of Cloud Run Invoker, right? Otherwise it won't work. So that's probably the most important part. Right, so I've generated the file, you can see in here, right? And then this is the Cloud Run service. If I refresh it, it should have already processed the file. Yes, you can see this is 200 request success, then it processed the file. If we now go to our decrypted bucket, and now you can see this is all nicely decrypted CSV. If I again download that, just to show you what the content looks like. And there you go. So you can see this has been decrypted, right? So that's the basically end-to-end solution. One more thing. One of the things you can do is also to set up the subscription to BigQuery, right? So this is the thing I was mentioning earlier. If you just want to log it, right, and understanding the message cannot be decrypted, but you don't know which one it was, you have the message ID, everything that you can reference, and then you can actually use a BigQuery subscription from PubSub to actually keep all of these historical metadata of every single event that got triggered, right? So then later on, you can cross-reference it to see which file had a problem based on your logs with this. So this can be very, very handy. Okay, finally, let's summarize. So today we looked into GPG, and we know it's a commonly used encryption technique via asymmetric encryption, which also means public-private key pairs encryption is typically designed for transferring data between different parties, because the data owner that want to send the data gets the public key, encrypt the data, they can only encrypt data, and then send it to you as the data receiver who owns the private key, and you are the only person or the only party can decrypt that data. It's a very secure form of encrypted data transfer or file transfer without involving sending around keys. And if you have an FTP server, sensitive data must not be stored in there without encryption. This is where GPG comes in again. Then if you need to do this, and then the file must be encrypted in GPG, just do it, and then otherwise you have a lot of different problems if you get compromised, all right? And it's considered more secure to double encrypt hypersensitive data on GCS. GCS has encryption at transfer and also at rest. So, but for very hypersensitive data, you may not want to just store them like that. And this is where GPG can be very useful again to actually store the data. Especially if someone is transferring data into your GCS bucket, even they can do it directly. They can do a double encrypt using GPG and then land the file with encrypted format on GCS. So if the organization somewhat accidentally grant a role for someone who is not supposed to see the data, they have not had a breach yet because the file is still encrypted. You need to decrypt it to see it, which are two separate levels. So files landed on GCS can trigger notifications to PubSub. This is limited, as far as I know, on the same project. So on the same GCP project. So when you set up the trigger, the target has to go to the PubSub topic in the same GCP project, right? Just to emphasize that. So if you have the cross-project thing, this will not work. So you have to add another thing to probably relay the event between projects. And then the metadata is very rich. And then you can use the metadata to do stuff. And this is what subsequently led to our Cloud Run service, which is very powerful and is serverless and stateless for file decryption. Because the key are all stored securely in Secret Manager. We do not store keys physically in any of the services that we run, right? Because Cloud Run, in this particular case, I've configured it to go back to 0 workers when the decryption is done, and that means the key is imported into memory, is dynamically used. When it's done, it will shut down the service, then everything is clean. That's very powerful. So the same technique can also be used for encrypting files via GPG. So this is the snippet file I showed you at the very beginning of the demo. that are used to trigger the encryption. But if you need to do the encryption, you need to create the service to send this data to third parties, or they give you an FTP server. Then you can also use the same technique to just wrap the service around, then run the encryption yourself as well. So keep in mind, this doesn't mean you can only deploy your encryption or decryption service with just Cloud Run service. Cloud Run also recently has put Cloud Run jobs in GA. So this also means if you have a batch job that is orchestrated through some other processes you have, let's say on Cloud Composer, this could be one of your last steps to send data to another service. And it can be very handy if you create a service in Cloud Run jobs to actually do the encryption and then export the files. Because if you try to install all of this GPG stuff on Cloud Composer, you have a nightmare. So I think that's something to keep in mind as well. Okay, so thank you very much for listening, and hopefully this was useful to you. And I think I certainly enjoyed building this. Thank you very much. I'll see you next time.
Go out!